Okay, so I'm going to show example one is an example on finding maximum area. Okay, so you look at the information. The information talk about a piece of wire to form a shape. The shape is a rectangle and a semicircle. So the first part needs you to need you to show the formula. So can you see if you go back to the theory that we mentioned, the area must be in terms of one variable. So in fact, if you take a look, the area that you are asked to show is in one variable. The variable is x. So they will like you to come up with this formula. So they will like you to come up with this formula, but they only give you something about the wire and they gave you the radius or the dimensions or that. So that will be actually the challenging part because after the showing, this is the this is the area in one variable. So by right, after if you manage it, if you would like the maximum value. So remember just now the theory? The theory was to differentiate and let it be zero. So when you do this, you will have a special X. The special X is going to help you to find the value of area and it will help you to find the value of Y. Okay, so everything is there already. So if let's say really time is running out, you might even do the differentiation first. Okay, but then what is the approach to doing that? So first of all, I will observe the area. So obviously the area is made up of the rectangle. So the rectangle will be 4x length and breadth. And there will be the semicircle. Semicircle will be half pi r squared. The r is 2x. So if you try to explore the area, you realize that the area has two variables. So if you look carefully, the area actually has two variables. If you compare to what they would like you to show, okay, this expression only got x, but your current expression has x and y. So you must be getting rid of x and y. So definitely you will need to get rid of you need to get rid of the y. So how are you going to get rid of the y? You use the information that they give you. So the wire will tell you about the parameter. That means, right, if you go, the wire can go around the parameter. So I'm going to make use of that piece of wire. Okay. So I'm going to make use of the piece of wire. So the parameter is going to be 6 pi. So what is the parameter made up of? There will be 2y here. And then there will be a 4x. And there will be a semicircle circumference. So semicircle circumference half 2 pi r. The r is 2x. 2 pi r is circumference. So in case you get confused, 2 pi r is the full circumference. So I'm not getting a full circumference. I'm getting a semicircle circumference. So sometimes some people will make careless. And the parameter, I know that it's going to be 6 pi because that's supposed to be the wire. So if you do that, you got a 2 pi x. So what's the purpose of using the parameter? The purpose of using parameter is to get rid of the y. So I'm going to manipulate. I'm going to make y my subject. I'm going to make y my subject. And So by right, if I can substitute the y into equation 1, logically I should get the expression. So this is the challenging part. So some people find this very difficult. You need a lot of patience and you need to make sure your menstruation doesn't have mistake. Okay, so it looks very, very complex. Okay, you check out the expression. They kind of group the x square together. So you focus on the x square first, this part. Slowly focus on the x square. So if you focus on the x square with the pi, it will actually give you minus 2 pi x square. Then you can factorize out the x square. Try factorizing out the x square. And that's actually your expression. So that's how we prove an expression. And then subsequently, the next one, I'm supposed to find the x that can give me a maximum area. For maximum area, I should need to differentiate equal to 0. So whether you achieve the expression or not, okay, whether you achieve the expression or not, you still go for your differentiation. So whether you achieve your proving or not, you can always just go for your basic differentiation. So this whole chunk here is just a constant. So don't be tricked by it. It's just a constant. So differentiate x squared is a 2x. And this is also a constant. So I'm getting a 12 pi. So all in all, that will be my dy, dA dx. So now I'm going to set my dA dx equal to 0. Your aim is to get the special x. So it doesn't look so complex because pi is just a number. Okay, if in fact you go and punch out calculator. So usually when I punch out calculator, I will write a few more decimal place before I give the 3SF. Okay, why do I do that? Because if I need to use the X, I wouldn't use a 3SF. I will use a more accurate one. So if you look back, I already found my X. So I need to find my Y. I need to find my A. So very simple. Do you realize that you already got a formula for Y? You also got a formula for A. So are you aware that you already got a formula for Y and you already got a formula for A? So all you need to do is sub in the X, but of course you sub into, you sub the more accurate one. You sub the more accurate one in your formula for Y. Or else you will risk some amount of inaccuracy. So you will get 2.64. Okay, then the same thing, you also sub into your A. So it's a lot of punching calculator, but please try to preserve the accuracy. And then you just punch calculator and give it to 3SF. So all in all, you answer the question. You answer the question for X. This is the X when there is a maximum area. This is the Y when there's a maximum area. And this is the area when the maximum area happens. Okay, so you answer the question. But then, right, in this question, they didn't ask you to prove that it is really maximum. So you can do without it. They never ask you to prove, or they never ask you to determine. Okay, so this is a case of maximum area, how we get the area formula in terms of one variable, and how I differentiate that area formula. Okay, so that is just one example first.